Hello, my name is Zoe Turner, and this is my motion of a falling object for my Lab 2. In this little overview, we're going to go over the introduction of the lab, experimental design and setup, data and analysis, comparing the data together, and then ending with a conclusion. So in this lab, we analyze a motion of a falling object, and in one part we only account for gravity, and in another part we account for drag. And we do this using Newton's second law with the velocity update and position update formula. So in my experiment, I dropped a stress ball from the length of 3.2 meters. The ball is approximately 0.023 kilograms, and my surroundings were air and earth. So as you look at the data, I set the origin at the middle of the ball, and the y-axis is negatively going downwards because I dropped the ball from 3.2 all the way down to 0. And the x-axis in a positive direction. And as you can see in my data, it's going from approximately 3.2 all the way down to 0. So a little bit into analysis, I observed that the ball traveled farther in every time step, which meant that velocity increases and that there was a non-zero net force. In the coding one where I only observed gravity, I had the same parameters, but I had to calculate weight force and update position and velocity with Newton's second law and update Fnet. So as you can see here, you might be able to tell that for j hat, I put 0,01 instead of -1. I did this because it was easier for me to understand the data in positive numbers than if it were in negative. And for gravity and drag, here is my little calculations. I did the same thing for the force drag and calculated the magnitude. And I also updated Fnet. I made corrections to the B component because I wanted it to end in the same position from when the tracker one ended. So I was able to get updated and have them end in the same part, and in my diagram, the force area for drag. Also here you can see where I calculated drag. I did the drag magnitude times drag D, and that's how I got the force drag. Here are my results. So as you can see, model 1 was on the trigger almost every part except for when it got a little towards 0.3, and then that's when it started losing its accuracy. But in model 2, it still had its accuracy throughout the entire thing. The only time where it wasn't accurate is where it slightly over-predicted. And like I said earlier, these in the observed model versus model 2, it was very close to the graph. And in the observed model versus model 1 with only gravity, it predicted really well early on, but wasn't accurate as time went on. And that's the important factor. So what does this mean? This means that drag is crucial for Fnet, and gravity is not the only force acting on a system. And it shows that in the second model, it predicts terminal velocity. So what if the object was thrown and not dropped? Well, it'll start with high velocity, but it'll eventually slow down, also known as leveling off to the terminal velocity. So in conclusion, some possible errors. Movement on the x-axis and a couple of distortions. But in my model, the gravity versus drag force, it is much more realistic than my model 1, which was just the gravity. And in my results, I saw that velocity will gradually become terminal, which is slowly leveling off. Thank you for watching my lab video.